Here we go. Everybody on point. 10, 9, 8, 7.
Welcome back to round 3. Thank you for joining us again from Cape Canaveral Space Force Station in Florida, where we are ready to launch Terran 1, the world's first 3D printed rocket. Today's flight is named Good Luck, Have Fun, or GLHF for short, and this is Relativity's first launch. We'll be bringing you live coverage from Launch Complex 16, which is our launch pad at Cape Canaveral, as we prepare for historic liftoff. I am Rachelle Aniceto, the Chief of Staff for the Vehicle Architecture and Technology team at Relativity Space. I support our Chief Architect, Kevin Wu, in the design, development, and product management of our medium to heavy lift reusable launch vehicle, Terran R.
And I'm Arwa Tazani Kelly, Technical Program Manager for Test and Launch at Relativity Space. I'm responsible for supporting the teams that design, build, and operate our test and launch sites across the country for both our Terran 1 and Terran R vehicles, including operations on the stages, engines, and propulsion components. Together, we'll be guiding you through our third launch attempt today. Now, if you joined us on March 11th during our second attempt, you know we came very close to launching with 2 aborts during terminal count. Here's a quick breakdown of the reasons for those aborts. During the first abort, we experienced an issue with the stage separation automation system a few seconds before T0 that properly aborted at T-minus 0.5 seconds. Then the team pushed an update to the vehicle automation system, successfully recycled the vehicle, and secured a new T0 time, which was during the last minute of our launch window. After recycling at T-minus 45 seconds, we had an automated abort on the second stage fuel pressure, which was only 1 psi outside of the limit. Let's hear more about our previous attempts from our Chief Engineer, James Harris.
Hi, I'm James Harris. I'm the Chief Engineer for Terran 1 here at Relativity Space. On our first launch attempt on March 8th, we had a ground system issue that prevented us from getting our liquid oxygen temperatures as cold as we need for launch. So after trying to work through that, we ultimately had to scrub for the day because we couldn't hit what we call our launch commit criteria, or LCCs, on those temperatures. We were able to solve the ground system issue pretty quickly, and we were back out there again on March 11th, and on that day, as you guys know, we lit the engines and got as far down as T-minus 0.5 seconds. At T-minus 0.5, we check our last set of launch commit criteria, and what happened that time is we tripped a criteria on what was calculated as a leak rate. We were able to find the cause of that in the automation and fix it quickly and turn around into another attempt. The second attempt aborted because our fuel tank on stage 2 was slightly outside of pressure bounds, and again, that's something that we can very easily fix. We've really learned a lot from these first 2 launch attempts. We've really nailed down our ConOps and the flow of how the operations day goes, so it's pretty smooth now. In the second attempt, we had really excellent propellant temperatures and we're well conditioned and ready to fly from that point of view. We also got a really important data set of running all the way through our countdown down to T0, including lighting the engines. Getting that data set lets us then check all of our other abort criteria to make sure we weren't going to hit anything else. And what we found is that the only issue we had on the March 11th attempt was that one pressure decay red line, which we were able to fix by changing the valve close timing. So that data set really gives us the confidence that we have our automation and our abort criteria ready for the next launch attempt. I'm really excited to go into the next launch attempt. I think we got the last couple pieces of data that we needed to make sure that the next attempt here is going to be successful, and all of our automation and abort criteria are going to get us there to a successful release.
A quick mission status update here. We are, as you see, holding the clock at T-minus 25 minutes. Our launch time right now is delayed due to two reasons. So we had the upper level wind shear being outside of stage 1 gimbal limits. However, the latest balloon data did show that it is now within acceptable limits. So we'll be keeping a close eye on that, and we'll hold the clock as necessary if needed closer to launch. However, now there is currently a boat in the range. So we are holding the clock and waiting for the range to clear that boat out of the hazard zone. We'll keep a close eye on it and give you an update shortly here once we know what happened. If you're just joining us, just as a reminder, we are holding the clock at T-minus 25 minutes due to a boat being in our hazard zone. We're holding until the range clears that boat so we get that green. We are still holding the clock at T minus 25 minutes for a boat in the hazard zone that we're waiting for the range to clear. While you're waiting here, I know that you see a big ball of fire next to our vehicle. I just wanted to tell you all that not to worry, that is on purpose. That's just our flare stack, and it's used to vent flammable gases from prop loading and venting operations and priming of the engine igniters. We're going to continue to hold until we have that update from the range. We are currently coordinating with the range for a new T0. We expect to get that new time in the next 5 minutes, so we are currently standing by.
Announcement on countdown. We have coordinated new T0 time and are currently targeting 03:05:00. The clock will resume in approximately 5 minutes.
As you heard on countdown, we are targeting a new T0 time that we have now confirmed with the range at 23:05. Again, that's 23:05 Eastern. The clock will resume shortly according to that launch time. All right, the clock is rolling. We are just under T minus 25 minutes now. We did receive confirmation that propellant loading is complete for both stages. We're going to keep an eye out on those upper level winds and on the range today, but the vehicle is healthy. So as of now, we're proceeding with 2305.
Thank you, Arwa. Arwa will continue to provide regular status updates over the course of the countdown. In the top left of your screen, you can continue to find our countdown clock to follow along in our pre-launch operations.
And now a quick reminder about the purpose of Good Luck, Have Fun. This is a first launch, meaning that while we're aiming for Terran 1 to reach orbit, our primary focus is on gathering the data and learnings necessary to develop Terran R, our much larger medium to heavy lift reusable launch vehicle. The lessons learned from this mission will also enable us to improve our software-driven approach to manufacturing.
And as a reminder, today's launch includes many firsts. Terran 1 is the first 3D printed rocket, which is 85% 3D printed by mass. It's in a race to become the first Methalox-propelled rocket to achieve orbit. If orbit is achieved, Relativity will also become the first venture-backed space company to have successfully reached orbit on its first flight.
And it's worth noting that while Terran 1 will be capable of lifting 1,250 kilograms into low Earth orbit, or LEO, today's launch doesn't have a customer payload. We do, however, have a memento aboard, one that's quite unique to Relativity that we'll tell you more about later.
Liftoff is currently scheduled about 22 minutes from now. This estimation may change as we continue to work through our countdown, but we will keep you updated along the way. Today's launch window lasts for 3 hours, and this provides us more time to troubleshoot any issues that could arise. And if any unforeseen issues arise during the countdown, we can pause the launch sequence if necessary, as you've just seen.
The window for today's launch attempt opened up at 2200 Eastern Time. The pad was cleared of all personnel at T-minus 4 hours, followed by the start of propellant loading, which has since been completed. We're now topping off our tanks and conditioning our propellant to the proper temperatures ahead of launch. Now at approximately T-minus 20 to T-minus 15 minutes, the launch director will poll the launch teams to ensure that all subsystems, weather, and the range are go for terminal count. Terminal count will then begin at T-minus 70 seconds, and that's when the vehicle's internal flight computer will take control of the countdown. Now, while we wait for T0, let's talk about the process that got us here.
Good Luck, Have Fun is the maiden launch of our 3D printed Terran 1 rocket. Terran 1 is an orbital class rocket, so reaching orbit would be the best possible outcome. But as you've heard us say before, we are truly looking for some important base hits here today. Notably, a key objective for today's flight is largely about proving our hypothesis that 3D printing is a viable way to manufacture a rocket and it can successfully withstand the pressures of flight. Through robust ground testing, we're confident that we have a real shot at proving just that. So the more data that we collect from this flight means that we'll have access to more insights, and this will give us the confidence that we're able to execute on Terran R and help us solve all the hard problems that come with building a medium to heavy lift reusable rocket. As a business, we're following a Pathfinder product development approach. So the Terran 1 that you see on the pad today has always been our Pathfinder. It was designed to be a development platform for Terran R, and it has served us exceedingly well to date in that capacity as we've progressed through printing and testing ahead of today's launch. Arwa, let's remind everyone what we would call a success for today's launch.
Absolutely. Again, safely clearing the pad, getting out over the ocean, and passing the point of maximum dynamic pressure, or max Q, would be a big milestone for today's launch. This is again because it's the point where the structural loads on the vehicle are the highest, making it one of the most challenging phases of flight. And this is the point in flight where we really want to prove much of what has already been proven on the ground. During acceptance testing, the vehicle withstood loads even beyond what we anticipate it will encounter during flight. So passing this milestone would effectively demonstrate that 3D printed rockets are structurally viable. And then if we make it even further to stage separation, we will have achieved a full first stage flight, and that'll be another big accomplishment for the team. From there, we'll attempt to light the second stage and get Terran 1 to orbit.
Stage 2 is targeting a 200 kilometer by 210 kilometer orbit, and this is not a traditional orbital target, but that is our target for today, given this is our first launch and not a customer mission. As a reminder, we do not have a customer payload on this flight since it's not a customer mission. So instead, we are celebrating how far we've come by mounting our first ever metal 3D print from the first generation Stargate printer inside of Terran 1's nose cone. Of course, it was a failed print since no one had done it before. Let's go ahead and take a look at this memento. So that piece that you're seeing there is about 6.5 inches in diameter and weighs about 3.3 pounds. That is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we've added a machined centerpiece with the GLHF and our mitosis logo to commemorate this maiden launch. We would be excited to see this memento get to orbit. But to take a step back and set expectations, we want to note that we are unsure how much of the second stage flight we will be able to share with you live. While we do have cameras on board, we will be prioritizing vehicle telemetry sensor data for this launch in order to maximize our learnings, and as a result, the video connection could be spotty. In the event that we do lose video, we will do our best to keep you up to date as we receive telemetry and information live.
And once again, we have strict safety protocols in effect for today's flight and are of course closely coordinating with the FAA and Space Launch Delta 45. These protocols are standard for all launches and ensure that no one would be in harm's way if there were to be an anomaly. Now, from our very first failed print 7 years ago, it's taken a relentless focus on innovation and almost countless iterations to get to where we are today. The world's first 3D printed rocket on the launch pad here at Cape Canaveral. And like the first print, Terran 1 is the first step of many towards making humanity a multiplanetary species. Now, as a reminder, our primary objective for today is to gather as much data as possible to help develop our future vehicles, including Terran R, our larger medium to heavy lift reusable launch vehicle.
Up next in our countdown will be the go, no-go for launch, which is expected to occur in the next several minutes. Let's take in some views of Terran 1 under the lights of Launch Complex 16 while we wait to hear from Mission Control.
Once again, everyone, we are currently standing by for the go, no go polls from Mission Control. This should occur in the next several minutes.
Announcement on countdown, this is LD. We are going to pause the clock at T-minus 10 minutes to assess high-level winds. We'll update briefly with a new T0 time once we get new balloon data.
All right, as you heard from our launch director, Clay Walker, we are going to hold the clock at T-minus 10 minutes. We're currently evaluating those upper level winds and just make sure that the wind shear is okay with our stage 1 gimbal limits. We're going to coordinate with the range and make sure we have the proper data that is within acceptable limits before we have a new T0. Stand by. All right, everyone, we are currently looking at an updated launch time of 23:25 Eastern. That's 11:25 p.m. Eastern. We're going to wait for that final confirmation from the range, and then we'll pick up RT clock accordingly at 23:15.
As we continue to hold, let's take a moment for those that missed the previous broadcast to do a refresher about the Terran 1 architecture. Let's go ahead and look at Terran 1 on a graphic up on the screen. So starting from the left-hand side of the vehicle, this is the bottom where we have the 9 Aeon 1 engines. In our previous broadcast, we talked about these engines getting printed using powder bed fusion or PBF technology. Each of these engines has a thrust capability of 23,000 pounds at sea level. This gives us a max total liftoff thrust of more than 200,000 pounds. The Aeon 1 engine is designed with a gas generator cycle, and we have thrust vector control actuators, or TVCAs, mounted on these engines in order to gimbal the vehicle during flight. We have completed more than 2,000 engine hot fires and over 10,900 seconds of runtime across Aeon 1 hot fire tests. The Aeon 1 engines are attached to the vehicle through the thrust structure. This is what takes the load from the thrust of the engines. And above the thrust structure is the stage with WAM printed tanks. This is our wire arc additive manufacturing in-house process. These tanks hold liquid oxygen on the top and liquid natural gas on the bottom. These tanks are pressurized during flight using an autogenous pressurization system. This works by running propellant through heat exchangers mounted on our engines, which convert the liquid propellant into a gaseous state, and this is piped into the top of the tanks to maintain our ullage pressure, or the required pressure for the tanks. Above the Stage 1 tanks is the WAM printed interstage, and this holds our stage separation mechanisms that separate Stage 2 from Stage 1 during flight. This is a pneumatic pusher system. And above the interstage is Stage 2, which has a single Aeon vacuum engine that is also printed with PBF. This engine has a thrust capability of more than 25,000 pounds in vacuum and has...
Announcement on countdown, this is the LD. We have coordinated a new UTC target time of 03:25:00. Clock will jump back to T-minus 16 minutes for go, no, go poll. And we'll begin count shortly thereafter.
Okay, there was that official confirmation of the new launch time of 23:25 Eastern. We are going to roll back the clock shortly to T-minus 16 minutes so we can go ahead and resume our go, no-go polling with our team of engineers and mission control, and we'll do that in alignment with 23:25.
And as we continue to wait, let's finish up on the Terran 1 architecture. As I mentioned, Stage 2 has WAM printed tanks just like Stage 1. And above Stage 2 is the WAM printed nose cone. So for future missions, this would be replaced with a fairing and also have a separation system. We don't have a customer payload as we discussed, but we did design Terran 1 for a payload capacity of 1,250 kilograms to low Earth orbit, or LEO, and 900 kilograms to Sun synchronous orbit, or SSO, for customer missions. All data from Terran 1 development will be fed into Terran R, and you can follow along our updates in the development, particularly for our Aeon R engine. We'll go ahead and take a moment to continue to look at Terran 1 out on the pad as we wait for updates from Mission Control.
As a reminder, we have coordinated a new T0 time of 23:25 Eastern. The T clock is currently paused at T-minus 16 minutes. We're going to resume that T clock in about 5 minutes, where we're going to go straight into the go, no-go polls with mission control. All right, T-clock is rolling. We are less than 16 minutes away.
All parties on net. This is the go, no go poll for launch. Please provide concurrence to proceed in the launch countdown with go, no go. VC, VC go. GC1, GC1 go. GC2, GC2 go. Ground, ground go. AVI, AVI go. FTS, FTS go. RF, RF go. GNC, GNC go. Flight software, flight software go. Thermal, thermal go. Prop 1, prop 1 go. Prop 2, prop 2 go. Fluids 1, fluids 1 go. Fluids 2, fluids 2 go. Loads, loads is go. Rock, ranges go. OSM, RC, RC go. Vehicle, vehicle is go. CE, CE is go. LC, LC is go. All parties have reported go for launch countdown. Once the clock begins to roll, anyone can call for a hold at any time. A hold is called prior to T-minus 70 seconds. The T-clock will continue to roll until T-minus 70, at which point a hold will automatically be initiated. A hold is not possible after T-minus 70, and any hold call after that will result in a terminal count abort. Should a hold manual be necessary, the person calling for a hold or abort should state clearly on comms, hold, 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 or abort, abort, abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify LD and RC on primary net.
And you just heard our launch director complete the go, no-go polling with our mission control team. As you heard, all systems are currently healthy, so as of now, we're able to proceed with our scheduled launch time in just about 13 minutes.
Throughout today's live stream, you've been hearing callouts from Mission Control. Let's take a moment to introduce you to our Mission Control team. Clay Walker, who you just heard, Launch Director. John Wiswall, Launch Conductor. James Harris, Chief Engineer. Elijah Escobedo, Vehicle Controls. Brian Batters and Zoe Dickard on Ground Control. Bill Stack, Ground. And Joy Mosdell, Range Coordinator. These are a few notable members, also from leadership, are supporting today's launch here at Launch Control. And this includes our co-founder and CEO, Tim Ellis, our Chief Operating Officer who leads product execution, Zach Dunn, Vice President of Test and Launch, Don Katterbeck, and Director of CAPE Operations, Pat Svatek. These are among the many, many others who are making today's launch happen. Let's go ahead and take a moment to pause and listen in for any other updates from Mission Control.
I think while we wait, maybe for our new viewers, let's give them a little bit more info about the systems that we're seeing on the pad once again. So the rocket rolls out of the hangar horizontally and is then lifted vertically by the transporter erector. That's the black vertical truss structure that you see behind the rocket there. The 4 large towers surrounding the pad make up our lightning protection system. They protect the vehicle from any direct lightning strikes. Inside of those, you'll see 4 small black posts around the pad called rainbirds. They're used for acoustic mitigation for the rocket and do so by covering the pad with water to dampen the reflected acoustics at liftoff. The small flame that you see there at the bottom right hand of your screen was once again the flare stack. No need to worry, this is perfectly intentional. It burns off flammable gases from propellant loading, venting operations, and priming of the engine igniters. It's a little harder to see, but the small slide-looking structure beneath the vehicle is our water-cooled flame diverter. It's used to mitigate the heat from lighting the engines, and it directs exhaust plumes away from the vehicle. You might also be able to see in this view 3 different levels under the rocket. So the largest and lowest level is the pad deck, and directly above it is the launch table. So this is where the launch mount pins to the pad and creates that flame duct. The launch mount on top of it is one component of the transporter erector. So it transfers loads into the pad deck during hot fire tests and engine ramp up at launch. It also contains the release system or hold downs and the quick disconnect or QD carriages that provide propellant and other commodities to the vehicle when it's on the ground. I do once again want to give a big shout out to the ground crews out here for all of their hard work. They've helped us build and operate this launch infrastructure and supported vehicle integration and testing. And of course, they helped us prepare the vehicle again for this third attempt. So thank you all so much for all of your incredible work. We did just get an update that, according to our latest weather balloon data, upper level winds are currently go. So the T clock is going to continue to roll.
Countdown sequence has started.
There you go. We are just 10 minutes away from this historic launch.
Filling propellant, supply targets.
We're currently at T-minus 9 minutes and 20 seconds. Now in the next few minutes until launch, you'll hear callouts from our engineers and mission control as we go through the final procedural steps before liftoff. We'll be pressing the tanks, priming the igniters, doing the final engine checkouts, retracting the strong back, and then getting that final go for launch. We're currently proceeding with the launch time of 11:25 Eastern. That is 23:25 Eastern. Let's continue to listen in.
Stage 1 pneumatics and transition to helium.
All right, we're pressurizing the propellant tanks to flight pressures with helium. As a reminder, during flight, we'll pressurize the tanks using autogenous
For engine chill.
pressurization. As you can see from these epic views, we are launching at night today, but in terms of our vehicle, it doesn't make a difference if we're launching during the day or at night. The systems operate the same. You are able to see those white clouds a little bit more clearly now. So that big white cloud you're seeing come out of the strong back is due to strong back chill operations. So we're chilling all of the ground equipment to try to get our locks as cold as possible for stage 2. Those smaller white clouds that you saw earlier coming out of the vehicle at different levels are due to the venting of the chilled gas from the rocket. And that venting into the humid Florida air out here is what causes the gas to condense into vapor and look like clouds. You can also see the frost on the rocket and what looks to be small white pieces falling off. That's all just ice, and it's because of the chilled propellant inside. It's so cold that you'll see ice falling off the vehicle.
Stage 2 igniter is configured for priming.
Arwa, let's walk through the launch timeline now that we're getting closer.
Yeah, at T-minus 70 seconds, the vehicle will go into terminal count, and this is when the vehicle's internal flight computer takes control of the countdown. We'll then go into final flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operations safety manager. At T-minus 6 seconds, we're going to see that blue fire and have ignition of those 9 beautiful 3D printed Aeon 1 engines. And then at T0, we will have liftoff and Terran 1 will fly. Shortly after, at T plus 2 seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly. And then at T plus 12 seconds, we'll begin our pitch over program. So we'll go downrange in an easterly direction over the Atlantic Ocean. And then at T plus 80 seconds is that very important milestone of max Q, where the structural loads on the vehicle are the highest.
At approximately T plus 160 seconds, we'll get to main engine cutoff, or MECO, where the stage 1 engines will shut off. This is followed shortly by stage separation, and the Aeon vacuum engine will ignite on the second stage. Second stage will burn for a little under 5 minutes. Then at approximately 463 seconds, we'll get to second engine cutoff, or SECO. We'll go ahead and tune back in to mission control.
Flight computer and vertical leveling.
As a reminder, GLHF is our maiden launch, so what we're really looking for here is to learn as much as possible and demonstrate the product concept. The big milestone will be reaching that point of maximum dynamic pressure, or max Q.
Stage 1 igniters are priming in. Stage 2 igniters, the flight target.
We're now priming those igniters with gaseous oxygen and gaseous hydrogen. In just about 30 seconds, we're going to be looking for the transporter erector cradle to disengage.
Stage 2 is on internal power. EE cradle disengaged.
All right, now those cradle arms are going to slowly release stage 2 so the strong back can retract. You can see the arms opening up there.
Stage 1 TVC checkouts running.
And now you'll be able to see the stage 1 engines gimbaling or tilting, as you see, while we're completing those final thrust vector control health checks.
Stage 1 is on internal power.
The strong back will be retracting shortly here.
Strong back is retracting.
There you go. We're retracting that black truss structure to prepare for
Stage 2 TVC checkouts.
for umbilical separation now that both stages are on internal power. And now we're doing those final thrust vector control health checks on the upper stage.
Starting final review of launch commit criteria.
Wow, we are very closely approaching T-minus 1 minute. I just want to remind all of us here that what you're looking at on your screen is 85% 3D printed, and it is about to fly. Next up, our range coordinator will ask the range for their final status.
Rock, report range status.
Range green.
That was confirmation. The range is green for launch.
Propellant closing out.
Flight computer configured for launch.
Under 1 minute.
LD, are you go for launch? LD, go for launch.
There's that final go for launch. We are just over 30 seconds away until the maiden launch of this vehicle. Good luck, Terran 1, and have fun. Here we go.
Ten, 9, 8, 7, 6, 5, 4, 1. Lift off.
Terran 1 has cleared the tower.
Switch over maneuver started. Proceeding to launch pad facing.
Look at that blue fire! If you can hear me over the cheering, the vehicle is now headed downrange in an easterly direction over the Atlantic Ocean. Our next ascent milestone is max Q, around 80 seconds.
Terran 1 is supersonic. Get telemetry switch over at the ground station. Max Q.
We are on our way to making a new history. Terran came ready to play today. You just heard that call out indicating Terran 1 just made it through. Max Q. We just completed a major step in proving to the world that 3D printed rockets are structurally viable. Up next, we'll be looking for a call out that stage 1 performance is nominal. Can see, we were waiting for MECO and upper stage ignition. This means that we had a main engine cutoff for stage 1, and directly following that we had second stage ignition, which you can see the Aeon vacuum engine in that beautiful view in the night sky. Reminder, there is no fairing for this maiden launch as we don't have a customer payload, but we do instead have a memento of the first ever circular test print. We are currently standing by for an update on what's happening with the stage 2 engine.
Announcement on countdown, this is the LD. There has been a T plus anomaly with stage 2. LC, please begin anomaly procedure section 25. Copy.
As you heard from our launch director, we did have an anomaly with stage 2 during flight. But maiden launches are always exciting, and today's flight was no exception. Although we didn't reach orbit, we significantly exceeded our key objectives for this first launch, and that objective was to gather data at max Q, one of the most demanding phases of flight, and achieve stage separation. Today's flight data will be invaluable to our team as we look to further improve our rockets, including Terran R.
Our team will now carefully analyze this data to determine what led to this outcome. So stay tuned to @RelativitySpace on Twitter and relativityspace.com for additional updates in the days and weeks ahead.
I want to thank the entire Relativity team for all of their hard work in getting us to this point. No one's ever attempted to launch a 3D printed rocket into orbit, and while we didn't make it all the way today, we gathered enough data to show that flying 3D printed rockets is possible.
As Arwo mentioned, we will apply the lessons learned today in our future vehicle, Terran R. What we are doing has never been done before, but it is undoubtedly a worthwhile endeavor that will transform the aerospace industry forever. And with that, we will conclude our coverage for tonight. I am Rachelle Aniceto. It has been an honor.
And I'm Arwa Tizani Kelly. Thank you, and see you next time.